In this lesson, we shall focus on polynomial division by using the box method, and we begin as follows. Right, we are doing polynomial division by using the box method, and we have the polynomial x to the fourth power plus 4x cubed plus 2x squared, all divided by 4x minus 1. And the couple of things we actually need to take into account, it is the fact that looking at the leading terms, right, x to the fourth power divided by x would give us x cubed. And the x cubed is actually exactly of the form ax cubed plus bx squared plus cx plus d. This particular notion of division highlights the fact that therefore we will actually, after division, have our ax cubed term here, bx squared here, cx, d, and in this particular block, we will put the remainder. Okay, but we take note of the fact that at the same time, we have the 4x minus 1. We have the 4x minus 1. So we put here exactly x to the fourth power. We take note of the fact that in our polynomial division, the top is called the dividend. The bottom is called the divisor. This way. So we have actually exactly x to the fourth power divided by 4x. X to the third power divided by 4. That's what we're getting. So if we multiply 4x by x to the third power divided by 4, what we're getting is x to the fourth power. Minus 1 times x cubed divided by 4 is minus x cubed all over 4. This way. Now we actually need to look at what we need to add. What term do we need to add here, or do we need to put here, so that the sum of this term with this would give us exactly 4. Clearly, we need to put here 17x to the third power divided by 4, or divided by 4. You can write exactly this way. So that then in the end, what we're then actually able to realize is if we add this and this, for instance, 17 minus 1 is 16, which you divide by 4 gives us the 4x cubed there. And now we continue with our division. So if we then say 17x cubed divided by 4, all divided by 4x, that one is going to give us exactly 17 divided by 16 x squared. So if you multiply these two, you get that. But if you multiply minus 1 times 17 out of 16 x squared would give us negative 17 divided by 16x squared. Now look, we actually add a term here. There's a term we need to actually put here such that the sum of this term with this would give us exactly 2x squared. And what term will that be? It will actually be exactly a 49 divided by 16 x squared, because 49 minus 17 is 32. When divided by 2, you get exactly 2 there. So if you then say 49 divided by 16, right, 49 divided by 49x squared divided by 16, if we divide it by 4x, what do we get? We get exactly a 49 divided by 64x. So if you multiply this with that, you get that. Multiply minus 1 by that, you get minus 49 divided by 64x. Okay. There's a term we need to put in this block here. Right, so that when we add this with this, you'd get exactly a 0, because there's no linear term here in the numerator. So now that must be exactly be a 49 divided by 64x, because if you add these two, you get exactly a 0. So if you then say 49 Right, over 64x, which is all divided by 4x. What we're going to get exactly a 49 divided by 256 there. So that when you multiply 4x by 49 over 256 is 49 over 64x. Minus 1 times this is minus 49 divided by 256. Okay, that's what you're getting. That is what we're getting exactly. So let's continue with our analysis of this polynomial division. So that now what we're able to achieve becomes exactly the following. So if actually we look at the remainder block, we need to therefore put a number here whose sum with this would actually give us exactly the constant term, which is 0, and that is going to be exactly a 49 divided by 256. So that then in the end, after the polynomial division, we get what? We get 1/4 x cubed. Right, we get the quotient which is at the top, plus 17 over 16 x squared plus 49 over 64x plus 49 over 256. Right, and then after this division, then we have our remainder. The remainder is this, which is exactly a 49. Right, over 256. All divided by the divisor, which is exactly 4x minus 1. And this is the result after the polynomial division. And this is the answer by using the box method of division. And we proceed right now to even analyze the next question as follows. Okay, now, first and foremost, we realize that at this point, if you look at the divisor, which is having two terms, then it actually tells you that the size of this particular box is going to be 2 pi. And then now you look at the fact that this is 1, 2, 3, 4. So it becomes exactly a 2 by 4. 1, 2, 3, 4. We just add one more block for the remainder. Just one more section for the remainder, and we move forward. Okay, we still have the box method to examine and to analyze, and we continue as follows. 4x cubed minus 2x squared minus 3, all divided by 2x squared minus 1. And now we continue as follows. Right, in the division at this point, we're going to actually consider that we're dividing, looking at the leading terms. We have x cubed divided by x squared, which is x. So it means, therefore, the answer is going to be of the form mx plus c, of the form ax plus b. In which case, therefore, we're going to have the quotient ax and b. And in this particular block here, we shall put our remainder, so that at this point, we're going to have exactly 2x squared over there. And then we're going to have exactly our 0x. Note that there is no x term, so there is 0x that is there. And then we have the minus 1. Okay, so we're going to put here 4x cubed. You divide 4x cubed by 2x squared, you get exactly 2x. So if you multiply 2x squared by 2x, you get 4x cubed. 0x by 2x, you get exactly 0x squared. Minus 1 times 2x gives us exactly minus 2x. So that at this point, we are analyzing our polynomial division by the box method. If you don't want to call it the box method, you also call it the generic. Right, it's also called the generic rectangle. Generic rectangle method. Right, it is either you call it the box method or the generic rectangle method. Okay, now let's continue with our analysis of this particular question. So we must think now of the of the term you need to put here, so that the sum of this with this would give us exactly minus 2x squared. So we must put here exactly minus 2x squared. So that minus 2x squared and 0 gives us minus 2x squared. So if you divide these, you get a minus 1. Yeah, so 2x squared times minus 1 is minus 2x squared. 0x times minus 1, you can put a negative 0x, which is 0x times minus 1. And then now, if you actually, therefore, continue with our multiplication, minus 1 times minus 1 gives us a 1. Right, so now we have the 0x. Yeah, we have the 0x. So, you see, if you have the 0x here, the question then is what you put here so that the sum is not, it's such that it gives us the x term, the linear term that is in the numerator. But clearly there's no x term in the numerator. And so now what you need to also actually be in a position to take into account, it is certainly the fact that if you add all these guys here, you must be able to get exactly a 0x, which means that you must put a 2x there. Right, we must put a 2x there exactly. Okay, right. So obviously, I mean, when you look at these, then the 2x divided by 2x squared, it's not divisible. The 2x is not divisible by 2x squared because the 2x squared has a higher power. So yeah, you take note of that. You need to put a number here whose sum is going to give minus 3, and that's going to give us a minus 4. Okay. So now, okay, you divide these two guys, which is 2x minus 1. And then what is the remainder? Right at this pointer, this is the remainder. So the remainder at this point is exactly 2x minus 4 divided by 2x squared minus 1. So in other words, we've been able to perform polynomial division by using what you call the box method, or what you call the generic rectangle method, or or sometimes what you call the area model. What you call the area model. Okay, obviously, that is what we actually can call this here, the area model as well. And we shall continue with our polynomial division. Let us look at one more little problem next. Next little example that we're going to discuss. All right, we have 3x cubed plus 4, all divided by x squared plus 1. At this point, we have exactly the following, yeah? We have exactly 3x cubed plus 4, all divided by x squared plus 1. And in this case, what we have becomes exactly the following. So we're going to put here the 3x cubed. We divide everything by x squared, but the x squared, obviously in the form of the decreasing powers, it's of the form ax squared plus bx plus c, in which case, therefore, we need to realize that we are missing a 0x term, and the constant is 1. Dividing x cubed here, just looking at the leading terms, and we have x squared, and the result is an x, meaning this is exactly of the form ax plus b, or of the form mx plus c. So if you divide 3x cubed by x squared, you have exactly a 3x. If you multiply these by that, you have 3x cubed. You have 0x by 3x, you have 0x squared. We have 1 by 3x, which is actually exactly a 3x. And then now, after this division, we need to think carefully. We need to put a term, an x squared term here, such that the sum is going to give us no x squared term, because there's no x squared there. So that can only be 0x squared there. And then I'll perform division. So the 0x squared you divide by x squared gives us exactly 0. We expect to put our remainder term there. Now, at this point, we have 0x by 0, which is actually exactly 0x, and 1 by 0, which is actually exactly 0. Here, we are looking at the fact that these terms here, now we need to put the remainder, but if you add all these linear terms, then we must get actually exactly no linear term. There's no x term there, so we must add here a minus 3x, because 3x plus 0x minus 3x gives us 0. Right, so there's no x term there, only x cubed and the constant. And therefore now you need to also add a number here such that the sum is 4, and the result is exactly a 4 there, we can see clearly. And therefore, as a result, we have put the remainder. And when you divide 3x cubed, right, so when you divide exactly our 3x cubed, right, by x squared plus 1, the quotient is what? It's exactly a 3x. And then what is the remainder, which is minus 3x plus 4, all divided by x squared plus 1. All divided by x squared plus 1. Right, so that is exactly what we are able to achieve. And this here in front of us is the result after the polynomial division. It is a result after the polynomial division. And so we are done with the polynomial division. And so, right, we actually will be trying the next little problem and seeing what we are able to achieve, of course. Bearing in mind that we're using the box method, or what we call the generic rectangle method. Generic rectangle method, or what we call the area model. What we call the area model. The area model. Okay, now this is so exciting, but very, very interesting, right, in the way we've done it. And also it is obviously a very important method of polynomial division that we can learn. And then now we're going to learn one more method. We're going to rather look at one little example. Let's look at the next example. Right, in the next example, we have 4x cubed plus 3x plus 5, all divided by 2x minus 5. We take note of the fact that looking at the leading terms, we have x cubed divided by x, giving us exactly an x squared. And this is exactly of the form ax squared plus bx plus c. Right, if you put here 2x and you put here minus 5, you see, this is clearly indicative of the fact that we have here with us the size of this is 2 by 3. 2 by 3, but you add just one more block for the remainder. And then we put here the 4x cubed. And if you divide 4x cubed by 2x, you get 2x squared. You multiply this, you get 2x cubed. Minus 5 by 2x squared gives us minus 10x squared. And therefore, if you add everything here, you have 10x squared, because there's no x squared term. So you add this one, so that 10x squared minus 10x squared gives us 0. You divide 10x squared by 2x, you get exactly a 5x. 2x by 5x is 10x squared, minus 5 by 5x gives us minus 25x. And therefore, you add here 28x. Divide this by that, you have exactly 14. And so if you multiply 2x by 14, you get 28x. You multiply minus 5 by 14, you get minus 70. Minus 70, so that when you add these here, it becomes exactly 75. Okay, so we get that one. And now this is the remainder, which is 75. So when you divide the 4x cubed, the 3x squared plus 5 by 2x minus 5, the quotient is at the top here exactly. So the quotient is exactly twice x squared plus 5x plus 14. The remainder is 75, all divided by twice x minus 5. Okay, so this is exactly the result after the polynomial division. So we have the quotient, the remainder, together with the divisor. So what you have here, this guy is called the quotient. The quotient. This one is called the remainder. And this one is called the divisor. And of course, we remember that this one you said is the dividend. And this one is called the divisor. The divisor. So this is polynomial division as we know it. And so this is very, very interesting to us. And we are pondering on this. And we are conducting our brief lesson on the polynomial division by using the box method. Let us try one more problem. The next question. Right, in the next question, we have exactly 6x cubed plus 5x squared minus 10x plus 3. You divide by 2x minus 1. So 2x minus 1. So you have this one is exactly 6x cubed. We put the 6x cubed here. We divide the 6x cubed by 2x. Divide 6 by 2. You get a 3. X cubed divided by x becomes exactly x squared. Right, so that's what you're getting. So if you multiply 2x by 6x, you multiply 2x by 3x squared, you get 6x cubed. Minus 1 times the 3x squared becomes minus 3x squared. So you need to put a number here whose sum is going to give us 5x squared, which is going to be 8x squared. Divide this one by 2x, which is going to be 4x. Multiply these, which is 8x squared. You multiply these, which is minus 4x. Okay, what number do you put here? Minus 6x. So you add these, you get minus 10. So if you divide minus 6x by 2, you get minus 3. Yeah, you multiply these two, you get minus 6x, and minus 1 times 3 gives us a 3. Okay, so now what number do you put here so that the sum is actually exactly 3? So you can only put a 0 here, and that is the remainder. So that in the end, after the division of 6x cubed plus 5x squared minus 10x plus 3, all divided by 2x minus 1, the result is the quotient at the top here, which is exactly 3x squared plus 4x. Right, minus 3, and the remainder is 0 over 2x minus 1. And therefore, the result is 3x squared plus 4x minus 3. And this is the answer. And this is the answer. Right, so we have performed polynomial division by using what you call the box method. If you don't want to call it the box method, it's called the generic. Right, it's called the generic rectangle. Generic rectangle method. You don't want to call these, don't want to call it this, you call it the area model. Area model. Area model. Let's call it the area model. Okay. Right, we must thank you for joining us. I mean, it was awesome having this discussion here, but awesome having this discussion. Until next time, take care and a very, very goodbye to you. Goodbye.